Assalamu alaikum everyone. So today I have here a really interesting question that is provided by my senior. Last Saturday we have a brief training session, and he gave me one of the easiest problems that he created, which is that we had to prove the sum of this given, I think, a partial series. This partial series is equal to 9. All right. So the way we want to approach this question is by first determining the general expression for the term. Anyway, so first we have to find a pattern. So what we can do here is by checking out each term. So let's say this is our first term. And what we can see here is that the value of 1 can be expressed in this form, which is the square root of 1. So now, we have a pattern, because it seems that the square root of 1 implies that for the first term, it will be presented as n is equal to 1. And then plus square root of 2 implies that we will be square root the n plus 1 term. So let me give you a visualization for the general term. So let me express it as a t subscript n, and it will be 1 divided by the square root of n plus the square root of n plus 1. Okay, so now the way we want to, we would like to express this whole series in another way, so that we could apply telescoping sum. And telescoping sum is a very powerful tool, because we could squeeze the series given into only such simple term we could solve from there. So what we're going to do is by multiplying the conjugate of the term, which is the square root of n minus the square root of n plus 1 divided by the square root of n minus the square root of n plus 1. And now, as you can see here, we will have the square root of n minus the square root of n plus 1, and the denominator will be n minus 1. And we are left with this, which is the square root of n plus 1 minus the square root of n. Okay, so now let us express the same series but in a different form with the new term that we have here. So the first term will be the square root of 1 plus 1 will be square root of 2 minus square root of 1, and then we'll be adding it with the square root of 3 minus the square root of 2. I'm going to create a few more terms to give you a really good idea of what we're going to do. So the square root of 4 minus the square root of 3, and then plus dot 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 up until the last term, which is the square root of 100 minus the square root of 99. Okay, you guys remember here we express it as square root of n, therefore our last will be the 99th term. So now, as you can see, there are terms where we could get rid of. For example, we have the square root of 2 and minus the square root of 2, which implies that we could just, well, cut it off from the series. So square root of 2 can be expressed as 0, square root of 2 minus square root of 2 is 0. This same idea goes for square root of 3. Let me do it in a different color. So like the square root of 3 minus the square root of 3 and so on. So, and square root of 4 will be, well, simplified as well. And the idea, let me write this down again. So this will be the square root of 99 minus the square root of 98 plus the square root of 100 minus the square root of 99. Now, if we perform the same pattern, the square root of 98, the negative square of 98 will be cancelled, and then the square root of 99 can be cancelled as well. So now, we have the idea of only we are left with two terms, which is the square root of negative square of 1, and then the other one will be the square root of 100. So basically, we have the square root of 100 minus the square root of 1. So we know that the square root of 100 will be 10, whereas the square root of 1 will be 1, therefore 9 shown. So it's a nice question, and we realize that it should be easy if you had the idea of what you are supposed to do. And I hope this really helps you to solve the problem. And yeah, I'll see you next time.